Hello. My name is Humphrey Solomon Jr. Welcome to my channel. Our today's video presentation is about conic sections in real life. You will see how important these conics are and why they are used. Before we continue, please watch my other tutorials and please subscribe to my channel, thank you so much. A common dartboard is made of concentric circles. These are circles with a common center. The closer to the center, bigger the point they will get. There are other types of dartboards. Here, each section corresponds to a numerical score. These sections have the same areas, giving equal chances of getting a hit in probability. In a square type of dartboard, some sections have a bigger area than others, having different probabilities. The shape of a Ferris wheel is a circle. This allows it to carry more people, because if it was a square or triangle or any other shape, it would be harder for people to get on and off. It's also easier rotated by its central axis. Do you know why manhole covers are circular? Because circular covers can't fall through a circular shaped hole, but other shapes can. Here is an example of a square shaped cover. You can see that it would fit in the hole if positioned in a wrong way, and it would fall right through the hole. Now let's see the parabolas in real life. A projectile is an object upon which the only force is gravity. Gravity, being a downward force, causes a projectile to accelerate in the downward direction. The force of gravity could never alter the horizontal velocity of an object, since perpendicular components of motion are independent of each other. A vertical force does not affect a horizontal motion. The result of a vertical force acting upon a horizontally moving object is to cause the object to deviate from its otherwise linear path. This is depicted in the animation above. According to Newton's law of inertia, an object in motion in a horizontal direction would continue in its horizontal motion, with the same horizontal speed and direction, unless acted upon by an unbalanced horizontal force. The animation above shows a green sphere moving to the right at constant speed. The horizontal distance traveled in each second is a constant value. The red sphere undergoes a vertically accelerated motion, which is typical of an object upon which only the force of gravity acts. Another example of an application of a parabola is a satellite receiver or transmitter. When the signal reaches the viewer's house, it is captured by the satellite dish. A satellite dish is just a special kind of antenna, designed to focus on a specific broadcast source. The standard dish consists of a parabolic surface and a central feed horn. To transmit a signal, a controller sends it through the horn, and the dish focuses the signal into a relatively narrow beam. The dish on the receiving end can't transmit information, it can only receive it. The receiving dish works in the exact opposite way of the transmitter. When a beam hits the curved dish, the parabola shape reflects the radio signal inward onto a particular point, just like a concave mirror focuses light onto a particular point. The point is called the focus of the parabola. In this case, the point is the dish's feed horn, which passes the signal onto the receiving equipment. In an ideal setup, there aren't any major obstacles between the satellite and the dish, so the dish receives a clear signal. Next, the ellipse. While Kepler's introduction of ellipses was an elegant solution for planetary motion, it was still merely an approximate description. Newton showed that a single planet orbiting the Sun would have an elliptical orbit, but in the real solar system, planets tug upon each other gravitationally, and their orbits are perturbed slightly from a perfect ellipse. In reality, no planet has a truly elliptical orbit. Kepler's laws, as they've come to be known, are a beautiful but approximate consequence of a deeper gravitational truth. Another example of an ellipse is a medical equipment. Lithotripsy is a procedure that uses shock waves to break up stones in the kidney and parts of the ureter. Ureter is the tube that carries urine from your kidneys to your bladder. After the procedure, the tiny pieces of stones pass out of your body in your urine. Electrohydraulic, piezoelectric, and electromagnetic energy systems use the focus of the ellipsoid to create the shock waves needed to fracture the stone. The waves are generated at one focus, and because of the elliptical shape, the waves are redirected onto the second focus, which is the stone itself. All of these waves cause the stone to crack, and it eventually fragments into many tiny pieces that can then be easily passed by the body. One more example of an ellipse is a whispering gallery. A person in a whispering gallery standing at one focus of the ellipse, can whisper and be heard by a person standing at the other focus, because all the sound waves that reach the ceiling are reflected to the other person. Now, an application of hyperbola in real life, are cooling towers in power plants. Hyperboloid cooling towers have become the design standard for all natural draft cooling towers, because of their structural strength and cost effectiveness of material. The hyperboloid shape also aids in accelerating the upward convective airflow, improving cooling efficiency. I hope I was able to give you a quick introduction of where conic sections are used in real life, and why it's important for us to study conic sections. I listed some of the links for the sources used in this video in the description below. Thanks for watching this video. Don't forget to hit the like and subscribe buttons below. Also, click the bell icon to get notified when I upload my next videos. Please share this video with your friends. Have a nice day.